61850 is on everyone's lips.
But what is really IEC 61850?
IEC 61850 is often mistaken as just a new communication protocol, as Modbus or DNP3. But it is far more than that.
Let's spend a few minutes to boost your knowledge about it.
The first edition of IEC 61850 standard was called Communication Networks and Systems in Substation,
and was focused on communication at power substation level, between relays, substation control and switchgear, to provide interoperability between functions from different vendors.
It was so successful that quickly it was extended to all network function and domain, like hydro generation, wind turbine, distribution automation system.
Another domain like electrical vehicle charging is under development.
And it is now called Communication Network and System for Power Utility Automation, and his scope continuously growing. IEC 61850 focus on 3 domains.
Communication, of course.
Because IEC 61850 split the technology communication and the application conceptual model to be future-proof.
It will be able to follow state-of-art communication technology, which evolves quickly when substation applications remain stable.
Data model, which define a virtual model of a substation with predefined object-oriented description.
And a description and configuration language called SCL, Substation Configuration Language, to support the engineering process of substation automation.
On top of this, the standard defines the test procedure to check the compliance of the device.
Before exploring this more in detail, we should present IEC 61850 substation.
The standard defines 3 levels.
We have, first of all, the process level where we have switchgear like circuit breaker and switches, and instrument devices like the current transformer and voltage transformer.
The second level is the bay level where we have intelligent electronic devices called IEDs.
IEDs is the new names of relays, to reflect their capabilities to take a decision based on logic and information collected from the process-level devices.
IEC 61850 defined process bus to allow communications between IEDs and intelligent instrument and switchgear.
Conventional CTs, VTs, and switchgear could also be connected through an analog-digital converter called merging unit.
The last level is called station level, and contains station SCADA, supervisory control and data acquisition, and HMI, human-machine interface, which are used to control and monitor the station.
Communication between the station level and the bay level are made through the station bus.
The 2 buses are optical fiber high-speed internet bus.
Before talking about communication protocols of IEC 61850, we should have a quick word about Internet protocol structure.
The Internet is based on 4 layers, means 4 independent level of services to deliver the information.
The top layer is the application layer. It is using a simple command to transfer data from one point to another.
For example, the application World Wide Web, www, is used by all Internet browser to access web page content.
Just under there is the transport layer, which is in charge to check that the information has been delivered correctly.
Through the network layer, which allows the data to hop from a different local network through the router.
Last, the link layer is in charge to transfer the information locally through switches.
The Internet provides a safe way to transmit data, from one point to another one, across switches and routers, but all these mechanisms are slow for real-time application.
To enable exchange between all the devices seen previously, IEC 61850 has defined 3 protocols of communication for 3 different applications.
The first one, and the most used, is MMS, which stand for Manufacturing Message Specification.
It is a standard Internet application defined by ISO 9506.
It is a client-server communication protocol, a private and secure conversation.
The client sends a request to a server and the server sends back an answer.
It is used for communication between the IEDs and the SCADA system.
To give status, make reporting or send control instruction.
The second is the communication breakthrough of IEC 61850 is the GOOSE message.
GOOSE messages stand for Generic Object-Oriented Substation Event.
They are used to send urgent messages between IEDs, like tripping and blocking, and replace hard wiring needed for selective interlocking schemes.
GOOSE message application is directly linked to the link layer, to deliver very quick information, in less than 4 milliseconds.
It is what we call a real-time protocol.
It is based on a mechanism called publisher-subscriber.
The message is broadcast over the local network to all devices who are listening.
As the transport layer is bypassed, there is no acknowledgement mechanism, but protection message is urgent and cannot wait.
Instead, the message is repeated during a certain time with an increased frequency.
Lost messages are analyzed and reported later on thanks to their time tags.
As the network layer is bypassed, Goose message cannot hop across router and stay in the local area network.
But, as the link layer encompasses the priority tag, Goose messages are being given priority by the switches.
Goose messages have a lot of advantage compared to a hardwired connection.
They are easy to configure and reconfigure without rewiring IEDs.
One fiber optic connection is cheaper than 10 copper wires.
EMC and EMI sensitivity is dramatically reduced.
Messages are delivered quicker than with wire connection, 4 milliseconds compared to at least 10 milliseconds.
But to work correctly, IEDs should be designed for it, not converted to it.
The last communication protocol is SMV, which stands for sampled measurement value.
As Goose message, SMV application is directly linked to the link layer and use publisher-subscriber mechanism.
SMV will allow current and voltage to be sent on a digital way, across the process bus, by a digital instrument or via a merging unit.
A merging unit transposes analog signal into a digital one, a discrete value tagged with synchronized time.
This voltage and current measurement could be used by any IEDs which need the information.
And this without additional wiring, just by using the process bus, which needs to have a sufficient bandwidth to support this large flow of information.
In medium voltage application, because of physical proximity between the relay and the switchgear, it is not much used today.
But the possibility to share value of voltage and current, and the absence of copper wired in the medium voltage compartment could be an advantage.
Due to the real-time nature of Goose and SMV application, standard redundancy configuration are not applicable.
To guarantee to deliver information, IEC61850 now define two schemes of redundancy.
HSR high availability seamless redundancy, which is a ring scheme,
and PRP parallel redundancy protocol, which is a double stars scheme. Both methods of network recovery provide zero recovery time, with no information lost.
Now we have described the communication process, we need to define the structure of the information.
IEC61850 has modeled all device and function in a switchgear with an object-oriented description.
The key element of this modelization is the logical node.
A logical node represents the smallest part of a function that exchanges data with a predefined name.
From a device from the process level like a circuit breaker XCPR.
Or a logical function from the bay level like an instantaneous overcurrent protection PIOC.
Or a function from the station level like the HMI called IHMI.
Each logical node contains a certain number of data. For example, a circuit breaker has a data called pose, which represents its position.
Data has data attribute which specified a parameter. Here we have STVal, which represents the status value of the position, closed, open and intermediate.
Data attributes belong to a function class, for example here it is a status.
Data attribute also have a type, here it is ADPS, double point status, open, close, intermediate.
And it is specified if this attribute is mandatory, optional or conditional. This one is mandatory. It means that every vendor should implement this data attribute in their IEDs.
IEC61850 gives the possibility to group logical nodes into a logical device. But this choice is free.
In this example, we have group instantaneous overcurrent, and time overcurrent into a logical device we called prot current 1.
Last, we have the IED which group the various logical device implemented.
This detailed definition must be followed to allow multi-vendors compatibility.
The last part of IEC61850 is about engineering, which is an advanced part of the standard.
Configuration is based on the SCL language, which is an XLM extension.
Tools have been designed to write the different SCL files.
The first step is to translate the single line diagram into an SCL file called SSD, substation description.
All selected IEDs also provide a self-description of their capabilities, which is the ICD file, IED capability description.
These two files are used in a system configurator to create a new file which is called SCD substation configuration description.
During this configuration phase, all interlock between IEDs are also defined.
The last phase consists to extract from this SCD file, individual configuration IED description, which is called CID file.
This file could be then transferred to IEDs to set automatically their configuration.
Even if this looks simple, multiple possibilities make this phase quite complex, and standardization of solutions is highly recommended.
To make a resume, IEC61850 is a universal solution to engineering a fully digital solution for power utility automation.
It is built in a way which can accommodate the future evolution of communication technology evolution.
It is allowing easy reconfiguration of the system without physical intervention on the ground.
It is allowing multi-vendors solution. Indeed, there is a lot more to say about IEC 61850, which is a complex standard of thousands of pages, but we hope this quick overview made you curious about learning more, so
Contact us.